Hello and welcome to some more computer networking goodness. Today we're on to lesson 9, which is looking at layers. So we're almost at the end here. We've covered most of wired and wireless networks, protocols, and layers. We've covered a whole bunch of networking in this series. Let's take it away. So the basic idea here is that sending data over a network is really complicated. There are many different things that we have to consider. Different applications. Are we using a web browser, an email client? Are we transferring files, etc.? Do we have to think about encryption and security? We have to split the data into different units like packets and frames. We have to worry about error correction and recovery. We have to worry about routing the data to the right place. What kind of cables are people using? Are they using Wi-Fi? What kind of Wi-Fi frequencies and channels are they using? And so on and so forth. The more you study networking, the more complicated it gets. In order to simplify the network communication process, the different activities involved in sending data packets are divided into layers. Each layer is concerned with a different task, and the relevant protocols are assigned to each layer. The layers are organized into the order in which the rules must be applied. So the key concept of layering is that we divide a big problem into a series of smaller sub-problems, something that we should be fairly familiar with from programming and the rest of computer science. We look at all the jobs and tasks that need to be performed in networking and divide them into a series of related tasks that we call layers. Put together, a set of layers can cover everything from the applications that we use online right down to the physical transmission of the data and back again at the other end of the connection. The definition that you should learn for your exams is this. What is a network layer? It is a division of network functionality. It covers a specific section of how network communications takes place. Learn that definition. It comes up a lot in the OCR exams. So the model we're going to be mostly concerned with is what we call the 4-layer model, or the TCP/IP stack. And this is 4 sets of related tasks that need to be done. We've got the application layer, the transport layer, the internet layer, and the network layer. So we go a little bit deeper here. We can see that we use different protocols at each layer. The layer is a set of jobs that need to be done. It's a concept. The protocols are actually what's happening. So the application layer, that might be something like HTTP. Transport layer is usually TCP. Internet layer is IP, and the network layer might be Ethernet or a Wi-Fi protocol. Then at the bottom there we have this physical connection, undersea fiber optic cables or whatever, that actually transport that data from one place to another, and then it goes back through that process, network layer, internet layer, transport layer, application layer, until it gets to the application that requires the data. Again, going a little bit deeper here, we've got all these different layers. You can see that each layer, you've got a range of different protocols, and each layer has this purpose, okay? So the layer is just an abstract concept. What do we need to do at this level? And then people have actual protocols that are actually specifically the set of rules for carrying these tasks out. And we can have different protocols at the same layer because they do slightly different things. So for example, the application layer, if you're using a web browser, you're going to use HTTP protocol. But if you're doing email and you're sending emails, maybe that's SMTP. If you're sending a file, maybe it's FTP. They're all application layer protocols. They do the same tasks, but in a different way for a different application. Layering is useful as it breaks down complex problems into smaller, more manageable parts. It is a concept that's not confined to computer science, but is frequently found in other walks of life like engineering. For example, many cars are built using interchangeable parts, with the same components being used on various makes and models of car. Different suppliers or developers can work to improve individual components without needing to modify other parts of the system. So if you design a better set of brakes, you don't have to change the rest of the car. In networking, each layer is self-contained. One layer is independent of the others. One layer does not need to know how the other layers work, but it can receive input from the layer above and then output data to the layer below. This allows developers to concentrate on one aspect of network functionality when working on new protocols. It means one protocol can be upgraded or even replaced entirely by a new protocol without affecting the rest of the network. So we can change HTTP to HTTPS because we want a secure connection, but that doesn't change the rest of the layers. All the other protocols can stay the same. We're just replacing one set of tasks from one protocol to another. Or when we develop a new Wi-Fi protocol because we want faster bandwidth, we don't have to change the rest of that TCP/IP stack that you saw before. Software and hardware manufacturers only have to be concerned with understanding how one layer works when developing their new products. It also means different companies can develop products that will work together. Layering helps ensure interoperability, this idea that different products and services can work together. Layering is also helpful when trying to identify and correct networking errors and problems, as the issue can usually be narrowed down to one layer in the process. So you have a look here, we can easily replace one protocol with another, thanks to layering. So we've gone from HTTP to HTTPS, but you see nothing else changes. And it's the same if we swap out that bottom layer, we go from Ethernet to Wi-Fi. Again, it doesn't change anything else in the stack. This concept of layering means that each layer has its own distinct jobs, and you can swap out the protocols that do the task at that layer without affecting anything else. Please remember that layer does not equal protocol. We use them together in the same idea, but they have different meanings. A layer is a set of related tasks that have to be performed. It is conceptual, it is an abstraction. A protocol is a specific set of rules for how a task is to be performed. So we don't change the layers, we change the protocols in the layers. The 4-layer TCP/IP model is just a concept. It's not something that actually physically exists. There is no application layer. It has been developed to help people understand how the different network protocols interact with one another and how they layer up together. The functionality required by a layer can be implemented by multiple different protocols. So for example, TCP is a protocol that is probably most commonly used in the transport layer, but applications could use other protocols to do the same job. UDP, Google's replacement that they're trying to launch called Quick. There's different transport layer protocols that you could use. In summary, the idea of layers is often used to help conceptualize the different network protocols and how they work together. A layer is simply a group or collection of networking protocols that work at a similar level within the networking process. Remember, a network layer is just a division of network functionality. It covers a specific section of how network communications take place. So networking layers can be a little bit difficult. Please rewatch the video, do a bit of research if you need to get the idea straight. You don't need to know it in a huge amount of detail, but you need to know how to define a network layer, and you need to know what the advantages of network layers are. Good luck with your studies, and I'll see you in the next video.